See, in module 3, we have finished almost LCD, keypad, 7-segment display, relay and motor. We will finish it now. In embedded core applications, we have SPI, I2C and CAN protocol and the project development. Okay, project development is okay, but when we say this SPI, I2C and CAN, we will have to see some other controller. Without that we will not be able to do this, because as I said, this 889 S52 doesn't contain SPI and I2C. So I'll say you this topic, but with reference to some other controller. Then what I'm saying is, here next is advanced C programming or Linux kernel. So almost we have finished the storage classes. We have not finished array, strings, pointers, functions. These are the things, but file operations, linked list. Okay, then what we'll do is, first, once we finish this, we will go with advanced C programming first, and then we will go with module 6 we will finish, and then we'll go with module 5.
Okay.
Then you have embedded systems development, embedded Linux, device drivers and memory mapping, RTOS. Okay, fine. You're looking job only in Bangalore?
Not like that.
Hello?
Hello? Yeah.
You are searching job only in Bangalore?
No.
No, okay.
We prefer, first preference is Bangalore.
Okay, now we have a recording. Get started. Okay, so when you say this DC motor now, this is a simple DC motor. Okay, now when we click on this here, what happens is you will have 2 directions given to this. Okay, now even though we don't connect any microcontroller or anything, even if we give power supply as well as ground, this should work perfectly. Okay, so our input I am giving something like, oh sorry, I am giving power and I am giving ground, then also this should work. Okay. If we run it, it is running, right? If I want to use the direction of this motor, I will have to change the ground and our power terminal, right? If I connect to power this side and ground that side, it will work in reverse direction, right?
Okay.
Right. Now I have to give one power supply. This is okay. Fine. Now what? But when you connect it to microcontroller, we cannot change the directions like this. We will have to give it like we are giving only 1 and 0s to control DC motor, right?
Yeah.
Right. So what we will do is, we will have some we will directly connect it to microcontroller. That means 2 terminals of this motor we will be connecting it to microcontroller. Now what operations we need? Now it's not necessary that our motor should run continuously in clockwise or anti-clockwise direction. We might have some operations where we need to use PWM, which is pulse width modulation, where you will have to control for how much time you want to run your motor and for how much time you want to off it, and again how much time you have to run it. Okay, so here if you see, can you see notepad? Oh no, notepad, actually I need whiteboard. Now if you see this, here you have something like, what is pulse width modulation is basically, this is our 1 pulse, this is our 1 cycle, right?
Okay.
if you see this is actually a cycle. Okay, this is one
Okay.
cycle and this is second cycle. Now if you see this is on time and this is our off time.
Okay.
Okay, so this is on and off for, suppose here I am saying that it is on for 5 seconds and here this is off for 5 seconds. Fine.
Okay.
And if you see this cycle, here I am saying that it is off for suppose 2 seconds and it is on for 7 seconds. I'm just
Okay.
giving the reference, that's it. So here we are changing the width of your cycle. We are having it like something like 360. If you say 360, then you have something like, if I have pulse of 10, that means I have something like 10 milliseconds pulse. In that 10 milliseconds, I am dividing it into half, which is 50 and 50. If you are saying 5 seconds and on and 5 seconds off, it means you have 50% duty cycle. You call it as duty cycle.
Okay.
Okay, here what we are doing, if it is this 2, this is 8. That means it is off for 2 seconds and it is on for 8 seconds.
Okay.
Okay, that means for 80% of the cycle it is on and for 20% of the cycle it is off.
Okay.
You can vary it according to your requirement. So that's why you call it as pulse width modulation, because you are altering the width of your pulse. You are modulating the width of the pulse. Pulse width modulation. Okay, so
Okay.
here you will have it in different concepts you can use. You are turning it on and off in various operations wherever you are using DC motor. Because every time you did not have like on and off at particular interval of time. Okay, so that we will have to see. Now if you see this pulse width modulation, again in this you will have on and off time, which is either you want to run it in unidirectional or bidirectional motor. That also you will have to select.
Okay.
Okay, now here you will have, if you see this particular thing, you will have two options. Either you can run in one direction if you connect the power supply, and then if you are connecting one pin of the microcontroller to one pin of DC motor, and the other pin if you are connecting it to ground, you call it as unidirectional motor. Because you are
Okay.
controlling it one side continuously, it is grounded, right? That means it will not be able to change its direction. You can either on and off through one microcontroller pin.
Okay.
Okay, if I am connecting in place of this particular, you are able to see Proteus.
No, I'm seeing drawing board.
नहीं तो खिलाओ बोले खिलाओ. So if you see, now you are able to see this, right?
Yeah.
Now if you say this, if I am connecting this particular pin to microcontroller, that means from here I can make it on and off. So here motor will either be running in clockwise direction or anti-clockwise direction, because we are connecting the second terminal to ground. If you connect both the terminals to microcontroller, then by giving 1 and 0 you can change the direction of your DC motor.
Okay.
Here you have one off condition, clockwise condition, and counterclockwise or anti-clockwise direction. Okay, now the other thing we have is how to calculate this duty cycle. We will have some duty cycle, I said, right? So how to calculate that duty cycle? Duty cycle is nothing but 1 by T.
Okay.
Okay, so here so if we are calculating it, something like 25% of, sorry, it's not 1 by T, it is like what T on by T on plus T off is the formula for it. Duty
Okay.
cycle formula is T on by T on plus T off.
Okay.
T on by T on plus T off. That means if I want 25% duty cycle,
Okay.
I want 25% duty cycle. then I am writing something like 25 divided by, here what I'll be writing for 25 I have on and plus the rest of it is 75, right? I have to make it 100. T on plus T of
Okay.
it is equal to 100, then 25 by 25 plus 75, which is 100. 25 by 100, I'll get 25% of duty cycle.
Okay.
Okay, so either you will have 25%, 50%, 75% or 100% is full power, which is continuously running.
Okay.
Now the thing is, you cannot connect your DC motor directly to microcontroller. Why? Because your motor will not, your pins will give you some particular amount of current, which is something like 5 milliamps or maximum of 10 milliamps, depending on how much it is. We will have to just check out the microcontroller pin, that how much it is providing. Okay, your DC motor can't run on this much power, it might take more current. So what we have to do is we need to connect it to some particular connector IC. So here we are using one IC called L293D. Here we will be using a motor driver. This is a motor driver IC. We will have to use motor driver IC, which is L293D. Okay, L293D. What does it do? It provides more power. Now, how this IC is how many pins does this IC have? We will see in Proteus then. So here we have L293D. Okay, here you can see L293D. Okay, this is the pin, but I don't know. Okay, it's working. Fine. Now, if you see this L293D IC, what does it contain?
Okay.
You can see that it is of 16. This is a 16 pin IC.
Okay.
Okay, so here your first pin is enable 1 and 9th pin is enable 2. Now here this is, you can drive 2 motors with this particular IC. If you don't want to use one particular terminals like input 3 or input 4, at that time you can simply disable this enable 2. If you enable first pin or 9th pin, that particular inputs and outputs will only work. If you enable 1, then input 1 and input 2, output 1 and output 2 will be enabled.
Okay.
If you enable both will work. If you don't enable anything, this IC will not work. Okay, and input 1, input 2, you can connect your inputs here. Here, that means your microcontroller, DC motor's input, you will be giving it here.
Okay.
And then you have here VSS, which is your power supply. And then ground we have to provide.
Okay.
Okay, so here we will be connecting this. It depends on your motor. If your motor is of 5 volts, well and good, VSS and VS are connected to 5 volts. If you are connecting 12 volts motor or 9 volts motor, you will have to connect it to 9 volts or 12 volts.
Okay.
Okay, now here, so what we are doing, we are controlling your DC motor. We are not giving output to your microcontroller. What we are doing is we are connecting your motor at this output 1 and output 2, and we are controlling it through microcontroller. That means microcontroller is giving us input, that whether your motor should be on or off. That input we are providing it to L293D IC, and the output of L293D IC is given to DC motor. Okay. Simply what we will be doing is okay, and the input we are giving it from microcontroller.
Okay.
Okay, so how we are going to give the input here is we are going to connect the 3 input pins to microcontroller. I'll connect only input 1 and input 2. Our wish we can connect anything. So P2.0, 2.1, and then I'm giving, we will do one thing, we can either give enable from microcontroller or directly give it to power supply, both will work fine. Okay, so first we have to write a program now. P2.0. See here, we need not declare anything that we are going to connect one particular DC motor or anything. Simply we are using some 3 pins, right? That's it. We are not doing anything else. So simply we need to use S bit for this and declare it.
Okay.
So S bit P2.1. 2.0, we are connecting it to some, oh no, input 1. That's it. Now simply write our main function. So we will have to write a delay function also. Why? Because we need to give some delay in between on and off if we want. Okay. Otherwise, first we will simply run it, and then we will have to use switch. We will use switch also. Switch at P1.1. So here what I'll do is, first I'll declare the switch equal to 1 as my input, and the other one I'll do is enable 1 is equal to 1 because we need to make it high. Okay, we need to enable this particular chip. Then what I'll do is simply I'll write one switch condition where I'll say that if switch condition is 1, just run the motor in clockwise direction, and if switch condition is 0, run the motor in anti-clockwise direction. We are not giving pulse width modulation, we are simply running it, either run in clockwise or run in anti-clockwise. If equal to 0. Then if we want to run it in clockwise direction, what we need to do, give like input 1 is equal to 1 and give input 2 equal to 0, right?
0. Yeah.
Else I'll copy this. Input 1 equal to 0 and input 2 equal to 1. That's it. So this becomes my switch condition. Error into okay. Oh, one more thing we have to do is connect a switch, right? So we'll select one button. P1.1. Run this switch. It is running in anti-clockwise direction because switch condition is 1. Okay. If we click on this, switch becomes 0 and it runs in clockwise direction. Okay.
No.
Okay. But still what we will do is, we are not going to connect DC motor in this way. We will be generally, if you want to protect your DC motor, we will have to use diodes in between. Okay, such that reverse current doesn't flow and your DC motor coil should not damage. In that case, what we will do is, in between output 1 and output 2, we will connect 4 diodes such that it will flow current in that particular way. I'll share one diagram with you which shows how, or else I'll just draw it on. It's difficult for me to draw it on whiteboard. Okay, I'll just share an image with you which will say that the current will flow in that particular direction and your DC motor will work, and we are going to connect that DC motor input to 12 volts. Okay, I'll try to draw that if at all, if it will be easy for you. Generally what we do is, if at all, if we are either we will be using, if we are using L293D, we will use L2 this diode. If we are not using, we will use directly your we will use sorry, relay. Okay, how we will use relay I'll show you, but before that, here what we will do is, we will just connect this in this way. We will connect, first we will connect one diode. Diode operation is, it will work only in one direction, right? So here is my motor, and here we will connect one more diode.
Okay.
Two more diodes we will connect. One is again in this way, and here one more. Okay, now what happens is, when you are connecting some input here, so the current input 1, as well as when you are connecting one input here, that means here this is my output 1 and this is my output 2. This is my output 1 and this is my output 2. So when you are saying that here you are giving 1, that here it is 0. So at that time what happens is, current will flow in, either it will flow in this direction.
Okay.
How the current will flow now, because you will have to see that whether the current is flowing in this direction or that. Of course you will have to give ground also, without ground it will not work properly. So now what happens, when all these 4 switches are right now open, okay, when you give this condition, at that time here I will have to give a power supply also, and here I will be giving ground. If you suppose this, at that time what happens, your current will flow in which direction now? Current will flow in, if you are saying that here the motor will flow, the motor will be flowing here in this way. and if you are saying here it will be running in this direction. Now how? See, here we are not, if we don't connect this, if you are getting output from output 1, at that time the current will flow in this way. Now how shall I say, here, from here the current will flow. Okay, so current will flow in this direction. At that time this diode will work, and this diode will not work. This is reverse biased diode, this is forward biased diode, so your current will flow in this direction. Okay, here the current will start. Here this is reverse bias as well as this is also reverse bias. So when you are saying this one, here the current will flow in this direction. If you say here 1 is given and here the condition is 0, at that time the current will flow here and your motor will be running in this direction.
Okay.
Only one diode will work at a time. If you are saying 1 at output 1, at that time if you say this is your 1 diode, second diode, third diode and fourth diode, at that time what happens is I am connecting switch here, and if you don't connect this power supply, so don't consider this as well as this power supply as well as ground. Now if you say my current is passing through output 1, at that time what happens, the current will flow through this motor and it will go to second diode, because only second diode is forward biased, rest of it all are reverse biased.
Okay.
Okay, the thing here, this is like, if you are connecting it like this and the current is flowing from this direction and the current is leaving this direction, you call it as forward biased. If you have that, like here the current is entering in opposite direction, then your diode is reverse bias and it will restrict the flow of current. So when you are sending your current through output 1, at that time only this particular, the current will flow through this motor, but it will follow only diode 2, because diode 3 is reverse bias, diode 4 is reverse bias, as well as your 1 is also reverse bias. If your current will flow in this direction through motor, then only 1, and here if I connect it to ground, the current will go in this particular ground and it forms a closed loop. And if I send the current to 1, output to 1, at that time what happens is the current will flow through your it will flow through first diode. The current will, because here it will enter through here, the current will enter through here and then it will pass through the motor and it will enter into 1 to ground.
Okay.
In this way you are connecting it to diode. Okay, all the 4 switches you can't use, as well as if at all if 2 diodes work at a time, at that time there is a problem that it might have a short circuit. So only one diode will work at a time. This is clear? You are using diodes just to protect your DC motor. That's it, nothing else. Now one more function. This is okay. Now we will do PWM motor programming with this delay function. Okay. PWM motor programming. Because once we see that, this will be finished. Now as I said, 25% and 50% we will write. You can use switch condition to write all the 4 conditions. If you use 2 input condition, I can have something like 25% duty cycle, 75% duty cycle, 50% duty cycle, 100% or 90%, depending on what you want. So I'll write one delay function here. Here I am writing like user defined delay. I am declaring and defining my function here itself. this is my delay function. Now what we are doing is we need 50% as well as 100%. So what I am doing is here, first I am turning on my motor. If switch equal to 0, turn on my motor, but this motor should run only for a delay of 50 seconds. So here I am giving delay of 50, and then what I am doing again is make this off. After 50, make it off. So input 1 is equal to 0, and then input 2 is also 0. Input 2 is equal to 0. Okay, so what happens here, you are giving some delay and then you are turning off your motor. Okay. But for how much time you want to turn off your motor? Again, that is like, give here delay of, as your duty cycle is 50%, so you need to give here 50. Okay. On. Okay. And here again, if I say 75, then I'll just copy this whole thing here. Here I will write like turn on for 75 and turn off for 25. Okay, you are giving simply an on and off cycle. For on for 50 seconds, off for 50, on for 75, off for 25.
Okay.
This is here something called PWM. That's it. Now, if we run this, you can see it is giving you some particular. It is not running continuously. If you observe, it is having a particular delay. On 1, 3, 75, 25. Okay. So this is your pulse width modulation. Now coming to your what you have relay. So how your relay is working actually is, without understanding that, we can't write your relay program. Relay program also we will write with this function only. So if you see this animated relay module, see, this is your relay module. Okay, can you see this? You are able to see Proteus, right?
Yeah.
You are able to see Proteus, right? Okay. Now,
Yes,
this is your relay module. Generally, we have 5 pins here for your relay. Okay. 5 pins relay, I am saying. We have different types of relays, but this particular thing I am saying it like this particular relay I am talking about. So here this is coil. So when you energize, this is called this is normally open, and 2 pins are there called normally open and normally closed. NP1 and NC, normally open, normally closed, and one is common pin. This particular pin is a common pin. Now here what we will do is, here we will be connecting coil to power supply as well as ground.
Okay.
So when you connect this to power supply and ground, what happens is the coil will get energized. When your coil get energized, here this particular pin which you can see, it will be fluctuating between your normally open and normally closed. So here if this is in normally closed condition, when you energize your coil, this particular wire will turn to normally closed.
Okay.
This RL1 is written, right? This is suppose normally open. Okay, and this is NC. This is NC. I think I can label this. Edit properties. No, I am not able to label one particular pin, but whatever pin is near your coil, that you call it as normally closed, and the pin where 12 volts is written, that is normally open. Okay, so generally this common is connected to normally open. When you energize your coil, this particular pin will turn to normally closed when you energize it. Like you can say it is a mechanical property, electromechanical property, magnetic property. Because whenever you have a coil and if you energize it, it will create an effect, right?
Yeah.
This is physics. So here you have, it will be turning your switch to this particular normally closed. When you get normally closed condition, at that time your motor will run.
Okay.
Okay, so if you are connecting your DC motor with this, so I'll rather than writing program, I'll show you this particular operation first with the direct DC motor. Okay, such that it will be easy for you. Now what I'll do is I'll connect this coil to power supply as well as ground. This is my power supply. This is my power supply, and here to I am connecting it to ground. Now here what I'll do is I'll connect one motor here. This is my motor. This is my motor. This I'll connect it to ground. Okay, and at the same time here what I'll do is I'll give this, actually I will have to give power supply to motor also, because that will not provide sufficient current. So I will just give my power supply to ground. Okay, now what happens is, so we'll see this. Okay, just a second, I will need one switch or something. I'll remove this. This is normally open. I will have to give an input condition to turn it on and off. So common and normally closed, so this has to be turned there, and I will have to turn this off and on. Okay, I'll directly connect it here only then. Fine, is it okay? I thought I just, shall I remove L29 3D? I'll use this relay. Okay, you cannot directly energize your coil through this particular pins. Okay, you cannot energize. Why? Because it is not providing that much current. Okay, why? Because for magnetic operations to happen, it will take some particular more time, more current, sorry, not time but more current. So you cannot directly do this. So what we'll do is we will connect it to some 2 point, again same thing, I'll connect it to power supply as well as ground. This pin, now I'll connect it to first, then this common pin I'll connect it to P2.1. Now this is by normally closed. Now we have to give some connections to your microcontroller to control it. Okay, so from there we will be controlling it. Our control has to be given to your microcontroller, right? So what we will do now is we will connect some particular pins to your microcontroller such that here right now if I give, just as we have written some program, we are not supposed to connect it like this. Okay, I am repeating again, we are not supposed to connect it in this way directly, but as we have written some program for P2.0 and P2.1, I am running it. If you see this is I'll just remove this power supply. And this is ground. Okay, so here what happens is why it is not executing. So if you see this here, it is a 12 volts relay, right? And our microcontroller is of 5 volts. So that's why here also it is not getting activated, because this power supply is also of 5 volts. We will have to change it actually. We will have to change the power supply. If we can edit properties, it is not allowing it to change for now. Okay. It's 12 volts. We will see. We will try to change it as 5 volts, whether it will run or not. I will see. Now it should work actually. See this. Okay, now what is happening, why it is not working is because first of all here you need to give power. As I said you, this power is not sufficient to run your motor, because this is simply a magnetic effect which is turning your switch on and off. So what we need to do, we need to give power supply to your DC motor. Okay, now if you see this, then also ground also we need to give. Now why it is doing this continuous operation is because it is continuously moving on and off. That's why it is running. So before stopping, the DC motor is running because of this delay operation. It is running continuously. If we stop your DC motor after a particular while of time, then it will not work again. Okay. If we give more delay, it will work properly. Okay. So this is how your relay works, but your relay should not be connected in this way directly. Here also we need to give power supply with diodes, then only it will work properly. I'll show you one diagram such that you will be able to understand that how it is working. I'll send you that diagram by drawing it in, or I'll just send it some. Mostly I'll try to draw a diagram, and I'll send you the circuit diagram for this. Okay. It's difficult for me to draw on that, and here also because the diodes and all I will have to search. The last one is your stepper motor interfacing. So your stepper motor actually works in unlike DC motor. DC motor is running continuously, but your stepper motor runs at particular what you can say steps. That means if at all if you say circle is 360 degrees, then here stepper motor will run at particular angles. If you have something like 3 revolution steps, I'll show you first of all how to use this. You can see this. I mean, here also without okay, so here if you see this, what happens in stepper motor is you will have one coil, and then here if you say this is one magnetic, you will have one magnetic coil here, okay? And if this magnetic coil, when you have this magnetic coil, what will happen when you energize this coil? What happens is it will create poles, right? So one becomes north pole and the other becomes south pole, or vice
Okay.
versa, right? Depending on
Yeah.
which direction you are passing the current. Now, other than this, what you will be doing is, here again you will be connecting these 4 copper coils. So when this particular what happens when you uh, send current through particular coil, again that will also create north and south poles. Okay, so now if suppose here I am passing current in such a direction that here this is north pole and this is south pole, so this is first one, this is second coil, this is third one, and this is fourth. Now suppose first I am passing some current in this fourth one. So what happens if it creates a north pole here and a south pole here, right? So it will uh, what you will say, deflect, no, attract, and one more word I'm not getting. It will move
Repulsion.
away from this north and north repulse. Yeah, it will just move away from this north pole, and either it will go to first or 3, right? This
Yeah.
is north and this is north, right? So it will
Hmm.
just move away from this, either it will go to first and 3. Now it depends on whether you are energizing 1 or 2,
3. Okay.
1 or 3. Okay, so in
Okay.
this way, so here if you say that here I am creating something like, here I'll connect, here I am creating north and north, so here it should become south and here north, then it will move away from 4 and it will go to 1. Similarly, then
Okay.
you energize 2, energize 3, energize 4. In this way, you are giving power supply to windings, such
Okay.
that windings will create a magnetic effect in both the coils, all the coils. Okay, now if you see this here, how to give this is, I'll erase this and I'll say that this is my winding A or 1, winding 2, winding 3, and winding 4. Okay, so if now first step, what happens, you can energize 1, right? If you are energizing 1 and keeping all others 0, it will move only one step further. It will simply reflect or repulse from first coil. Okay,
Okay.
then what you will do, what I'll do is, if I want to move it in
Okay.
clockwise direction, I'll off this and I'll turn on 2. So
Okay.
from 1, the motor will move to second one.
2.
That means it will move around, suppose you can say, if it is 360 degrees, then it will move 90 degrees. From 1 to 2, 90, 2 to 3 is 90, 3 to 4 is 90, again 4 to 1 is 90. So from first, I'll move 90 degrees to 2. Here I'll just make this bit as 0 again. Again what I'll do, here 0, 0. I'll energize my third coil and then
Okay.
I'll energize my fourth coil. So this will complete its one circle, one loop. So one
Okay.
coil we have to energize at a time. So we will be energizing 2 coils basically. One is one main coil and the other is whatever is around that main coil, 4 windings, that coil. So here we will be energizing in it such a way that it will move 90 degrees in any angle. Okay.
Okay.
So here what you can do is, you can find out that here how many steps you need. Here I have only 4 steps. These are called steps, step angles. This step angle
Okay.
is 90 degrees, right? Because I am moving, once I move, I am moving 90 degrees. So you call it as step angle. And I have only 4 steps here. So it depends on how many steps you want. You can write your program in that way.
Okay.
Okay, suppose you have to revolve, you need 180 steps. Then what to do? You will need something like how many degrees it should move in 2 degrees it should move in one step. So 360 divided by 2, you will get 180 steps. So how many, what angle you want to move, you have to divide it by 360. So here
Okay.
we are dividing 360 by 90, we are getting 4 steps.
Okay.
If you want 360 by 360, you will get 360 by 360, you will get 1. That means with one step you will be rotating only 1 degree.
Okay.
Okay. So here how to suppose if you want more steps, what happens? You have something like half step and full step also you will have. So how to write that particular thing is like, if I have 4 steps, then what I can do is, even I can have step, means you can say if you want to move in clockwise or anti-clockwise, from wherever you start you will have to continue that. You can't change the sequence. Okay, why? Because after 1 I can't go directly to 3. If you are starting from 1, go to 1, 2, 3, 4. If you are starting from 2, start from 2, 3, 4 and 1. 3, 4, 1 and 2. But you can't go like 1, 3, 2 and 4 like that. You can't change the basic sequence of it.
Okay.
Okay. So while writing program, again the same thing. If you want to write a program, how we are going to write? We are going to write it something like, simply we are making four wires, and that 4 cables. What we'll be doing is, we will be actually, the thing is, we cannot have that 4 wires here. 4 windings will not be present. Why? Because if you see this, you can see Proteus, right? If we open this and if we select stepper motor, you see first how many terminals are available.
Okay, I'm not able to see Proteus.
You are not able to see. You are able to see whiteboard, I guess.
Yeah.
I think now you can see, right? So if you see this by step, you can see this, right?
No, still I'm not able to see
Now
it.
you can see. You are not able to see. I have selected.
Yeah. Still whiteboard is. Yeah, now I'm.
Okay. So if you see here, you will have 4 terminals, right? If you connect these 4 terminals to this particular P3 point, 4 terminals are there. We will simply have to give like S bit input 1, S bit input 2, S bit input 3 and S bit input 4. Okay, so when you give like S bit equal to 1, so depending on this chart I can say, if you give 1 coil at a time, so input 1 equal to 1, input 2, input 3, input 4 equal to 0. Give some delay, and then again give input 2 equal to 1, input 1, 4 and 3 are 0.
Okay.
Whatever first 4 steps we have given. Here we gave something like this, right? We have drawn one table like 1, 0, 0 and 0. Next is 0, 1, 0, 0, 0, 0, 1, 0 and 0, 0, 0, 1. So these things you will have to supply it with S bit. S bit input 1, S bit input 2, S bit input 3, S bit input 4. Input 1 equal to 1, all other inputs are 0. Give some delay. Input 1 equal to 0, input 2 equal to 1, all others 0. Okay, just try this out. If it works, okay. If it doesn't work, tell me. I'll just we will execute it.
Okay.
Okay, so this is about your stepper motor. Just to try this out, and here when you select bi-stepper motor, the bi-stepper is simply that you are able to rotate it in anti-clockwise or clockwise direction. Otherwise you will be having some motor which will work only in you have actually, when you are selecting it here, you can see stepper motor like it is showing you unipolar. Unipolar means only one direction. Bipolar is 2 directions. Okay.
Okay.
So you can see this. Just try this out. Okay.
Okay.
So with this, I think basics of your 8051 are finished.
Okay.
Basics are finished, but you can understand how to play with it only when you practice it, so I suggest you practice it.
Okay.
The other thing is, now I will have to and you will have to, if we want to see some other software how it is working, then what we need to do is we need to install some other software. So we cannot install PIC13 because PIC software will work only when you have hardware, and moreover I don't have PIC software, so we can go with AVR XML Studio. But first what I'll try is I'll just create one. Whether it is allowing me to write program or not, I don't know. So we will try to do that. If it allows us to do in Proteus, then I will show you how to work with other controllers. If it doesn't allow me, then I will need some time to install some other softwares on this. Okay, if I don't execute it in this way, if I show you on notepad, will it be okay for you? Because as of
Okay.
now I don't have that software with me, so I will show you that, but for that also I need some. Okay, I'll try to show you. Because if I show that, then one good thing will be we cannot actually. If we go with AVR microcontroller, what will happen is it is easy for us to understand SPI and I2C. But if we are not able to write program here, then we will not be able to execute it. So first of all, I will have to see whether we are able to create projects here or not, because I have not added any files here. We'll try. I mean any external 80, 16. So if you see here, it has 16 KB of flash, it has SRAM, it has one EEPROM, it has ADC inbuilt, analog comparators, it has I2C, SPI, 4 ports, 3 timers and 1 USART. Okay.
Okay.
So if you see here, this IC also, you will have something like 4 ports are there. Here the name of the ports are not P1, P2, P3, P4, but it is PA0, port A, port B, port C and port D. Okay, and here you have again A reference and A VCC. Other than VCC and ground, you have 2 more pins called A reference and A VCC. Why we have is 2 pins are there for VCC as well as ground, but A reference and A VCC is for ADC. Separate voltage reference and voltage ground is given for voltage reference as well as input is given for ADC also. Okay, and you can see that this ADC is at port A. That means the alternate function of your port A is either it work like port A or work like ADC.
Okay.
I think it will not be clear with this. What I'll do is I'll just download some what pin diagram and everything. Download the software and I'll show you the SPI I2C interfacing in this AVR microcontroller. Okay.